Hey gang, so today we are going to do rational exponents. So grab your journals, we're going to take some notes. This is going to be what we call rational exponents. Rational exponents basically just mean that we're going to have a fraction as an exponent. Yeah, I know, you're like, what? Alright, hold on, let me pause this real quick. Okay. So I want to go over first a couple of forms. So the first thing I'm going to do is called parts of a radical. Okay, we're going to write that in our notes. Radicals, you've seen them before. A lot of times you call them the square root, but they're not always a square root. Sometimes they're a cube root, or the fourth root, or the fifth root, or the sixth root. So we're just going to call it a radical. In the little nook right here in the arm, there is a number. Now we don't always see that number, and I'm going to explain that here in a minute. And under here, we call that the radicand. So let me get my pens so I can. I'll go with this. This will work. All right. The N right there, we call that the root. Sometimes we'll call it the index. Sometimes we'll call it the what's the other one? Oh, the indice. But most of the time, we're just going to call it the root. Like, what's the root? The nth root. The A underneath here, this is called the radicand. And then the funny little arm-looking thing, we call that the radical. Okay. So most of the time, you'll hear me say the second root, the square root, the cube root, whatever it might end up being, but that's how we'll talk. So here's what our problems are going to look like now. We're going to have our base, which is what we're used to having, an x or something. And then we're going to have over 2/3. X to the 2/3 power. So you're already like, what? Okay, x to the 2/3 power. Here's how you interpret that. What this means, anytime you have a fraction, that means you have a radical sign. Now, let's have a little biology lesson. If I'm going to go out and I'm going to plant a seed in the ground, my seed, I'm going to water it, and my seed's going to grow, and it's going to grow up, and as it grows up, my plant, what grows down? Well, let's see. The roots, right? The roots are on the bottom. So, that helps me remember this. The root, which is the what goes in the little arm, is on the bottom. The plant roots are on the bottom. The roots of my fraction, that's the root. So that means that 3, this is a cube root. All right, the x is my base. It's going under here. So I need to figure out, where does that 2 go? 2 is the actual exponent on whatever is under here. So I'm going to put parentheses around the x, and I'm going to put it to the second power. That's where the 2 goes. So this is the cube root of x squared. Now, I could write it one other way, and I just want to show it to you. I'm going to say or. I'm still going to have the radical. I'm still going to have the x. I'm still doing the cube root. The roots are on the bottom. But there's another way I could have written it. I could have said big old parentheses, and that 2 goes on the outside. The really cool thing is it works either way, whichever way you want to do it. It doesn't matter to me. You'll find sometimes that, you know what, it's easier to put it under the radical and just keep it all nice and neat. Sometimes, you know, it's easier to have it out here. So we'll kind of explain it both ways. We're not going to dwell a whole lot on it. This is one question on our star. You get really into this in Algebra 2. I'm going to let my Algebra 2 teachers focus more on this. I'm just going to give you a little taste of it so you kind of know, if I have a fraction, I have a radical as an exponent. I have a radical underneath here. All right, so let's try this. I have a couple other examples. 4x to the 1/2 power. Now, the 1/2 power is very important. That's the one I need you to remember. Anytime you have a 1/2, you have a, wonder what I have. Let's actually see. Well, I see the fraction, so right off the bat, my brain needs to think, oh, I got that radical. Okay, the root is on the bottom. So on the bottom of this is a 2. So in the arm right here, I'm going to put a 2. 4x is going under here. Now, I could put, there's a 1 up here. I could put parentheses around this if I wanted to and put a 1. Or I could have put parentheses around the big one and put a 1 there. But when it's a 1, I really don't need to put it. So let's do this. Let's put the 4x under here. Now here's a question. Whenever you have a radical and you see this, can you tell me what that equals? Wouldn't you go, oh, well, that's just the square root of 9, so that would be, if I put that in my calculator, it would tell me 3. If I said the square root of 4, well, that would be 2, the perfect squares. Whenever this is empty, it's understood that it's a 2. It's the square root. That's the most common one that we're going to use. So when I have a 2 right here, I don't necessarily have to write that. I can write it just like this right here. I can leave that little 2 off. I don't have to write it. So let's take another one. Let's take 9x squared and let's raise it to the 1/2 power. Right off the bat, your brain should be thinking, oh, if I have the 1/2, that's just the square root. It's just a radical. The root is 2, but I don't have to write 2 because it's understood that it's a 2. Now, can I? Absolutely. I can put the root right there. This is 9x squared. It's to the first power, so I'm going to leave that off. I don't really need to put that. I could put parentheses and put a 1, but I'm not going to do that. Okay, so now here's where it's going to get a little tricky. I'm going to take this, and I need to kind of break it up. I need to think of it as 2 separate things. The square root of 9 and the square root of x squared. Okay, well, let's think about this now. What is the square root of 9? If I just had a 9 under there, what is the square root of 9? Oh, it's 3. Okay, so, let's kind of look at this. I'm going to take this, and I'm going to break it up. And I'm going to say the square root of 9 times the square root of x squared. Whatever's in here, I'm just multiplying it, so I'm going to break it up into 2 pieces. Okay, stay with me now. The square root of 9 is 3. I could put that in my calculator, hit enter, and my calculator's half dead, so I can't really use it. The square root of 9 is 3. But now I need to think about, what's the square root of x squared? Well, okay, we're going to go backwards now. You ready for this? I'm going to say x squared, a radical. Let's go back to the fraction. Well, the root is 2. On the outside is a 1. So this is x squared to the 1/2 power. Okay, well, remember when you have a power to a power, what did we do? Yeah, we multiplied. So I've got 3. What is 1/2 times 2? Well, if I had my calculator, I'd say 2 times 1 over 2 and hit enter. And you know what it's going to tell me? It's 1. So that means when you multiply this, you get x to the 1 power, or just x, which is 3x. What? Okay, I want to do that one again, but I want to do it without the radical and show you a little bit easier what I think might be a little bit easier. Okay, here we go. 9x squared to the 1/2 power. Okay, I'm going to write that right here. 9x squared to the 1/2 power. Okay, this is each of these bases raised to the 1/2. So that is 9 to the 1/2 power times x squared to the 1/2 power. 9 to the 1/2. I'm going to try and put it, I think, I hope I can. Oh, let's see, it's saying my battery is critically low. Okay, here we go. Watch this. 9 y alpha. Look at that. Is that not the coolest thing? I can actually put 9 to the 1/2 power. Oh, look at that. It tells me it's 3. I didn't even have to know anything. 9 to the 1/2 is 3. 2 times 1/2, I already know that that's 1. So that's x to the 1, or just 3 times x. So I could do it this way, term by term, or I can know that it's this way. You're probably already going, oh, this way is way easier. We'll do it both ways. You'll see. Okay, let's do an example. You're like, wait, wasn't that an example? It was, but let's do another one. Let's do the square root of 2x to the 4th power. Okay, so what's the square root of 2x to the 4th? You're like, oh, really, Mrs. Dean? Well, let's just see. I know that when I see a radical, that means I have a fraction. So what's my base? Well, my base is 2x. Okay, I know I have a fraction, so I'm just going to go ahead and put my fraction. So what's the root? What goes on the bottom? Well, the root is the square root. So a 2 goes on the bottom. What's the exponent? Yep, it's this 4. So it's 4. All right, 4 over 2. Does that reduce? 4 over 2? Isn't 4 over 2 2? So this is really 2x to the 2nd power. Hey, I can do that. That is 2 to the 2nd power times x. 2 times 1 is 2. 2 times 2 is 4x squared. Look at that. That actually wasn't too bad. All right, let's try this. Let's try 3x to the 6th squared. All right, so the square root of 3x to the 6th squared. Oh boy. All right, well, I see the radical, so right off the bat I'm like, okay, I'm going to have a fraction. So here we go. So 3x to the 6th is my base. I know I have a radical. What goes on the bottom? The root. The root is 2. On the top is my outside exponent, which is another 2. Oh, what is 2 over 2? Isn't that 1? I'm just going to mark that off and say that's 1. Anything, just take it to the 1 power, it's just itself. So that means this is simply 3x to the 6th. You're starting to think, that's not too bad, is it? I'm going to make sure I didn't miss something on my example. I had something different. X to the 6th. Okay, hold on. I want to make sure I didn't mess that up. I'm pretty sure we got it right. We did it right. I actually had a different example in there. Okay, we'll do my example next. I'm going to try and squeeze it in down here. What I did was 3x to the 6th squared times, I put a times on here, the cube root of 8x cubed to the 6th. That's what I did. All right, so you're like, what? Okay, I'm going to move that there so you don't see it. Okay, so we already know that this one right here came out to be 3x to the 6th, right? Put 2 over 2, oh, get that down just a little more. 2 over 2 when we simplified it, and so we got 1. So I know that this right here is 3x to the 6th times. Let's simplify this one. All right, so that is 8x cubed. I see the radical. What's the root on this one? The root's a little different. The root is 3. So on the bottom I have 3. The exponent is 6. 6 over 3 is actually 2. All right, so I need to fix this right here. So that's going to be 3x to the 6th times 8 squared, because I have a 2, and x 2 times 3 is 6. All right, well, we're getting close. 8 squared is what? 64. 64 times 3. I need to do these right here. 64 times 3. I have a little cheat sheet over here that already had it multiplied, 192. 6 x's here and 6 x's here. How many x's is that total? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That would be 12. And there it is. Yeah, you're like, what? Okay, let me do one more. 144 x squared y to the 12th, all raised to the 1/2 power. Okay. I'm going to do this term by term. I know with the fraction, I know that means I have a radical, but sometimes I can't remember how to do those. So I'm going to say it's 144 to the 1/2 power, because I think my calculator will do that for me. Then I'm going to multiply 1/2 times 2. Well, half of 2 is 1. Then I'm going to multiply 1/2 times 12. Half of 12, well, that's 6. Okay, that wasn't too bad. If I were to put 144 alpha y equals to the 1/2 power, my calculator would tell me that the square root of 144 is 12. I have an x and a y to the 6th power. Bum, bum. All right, so that gets us going on those radicals. So that's what's going in our journals. So take a second, make sure your journal's good, and then we're going to start on our worksheets. I'm going to do that video next.